A foam core can look ideal on a datasheet and still fail the application once it becomes part of an imaging table. Low density, structural properties, or a radiolucency claim may support initial screening, but they do not establish the performance of a completed sandwich structure. Skins, adhesive, inserts, coatings, local supports, geometry, and manufacturing conditions all influence the final result. Qualification must therefore begin by separating material evidence from device evidence. The supplier can document the core grade, density range, processing guidance, and material lot. The equipment manufacturer must define the finished construction, intended imaging conditions, structural requirements, risk controls, and acceptance criteria. Several acceptable components do not automatically create a validated assembly. The first evidence gate is material identity. The tested foam must match the foam intended for production. Grade, density range, thickness, lot number, supplier, conversion method, surface condition, and applicable datasheet must be unambiguous. Records should also distinguish typical values from guaranteed limits. The second gate is imaging compatibility. Radiolucency is a system-level requirement, not an isolated material property. Representative testing should include the planned skins, adhesive, edge treatments, inserts, coatings, and geometry. The modality, imaging condition, purpose of the evaluation, and acceptance logic must be established before results are used to support approval. Third comes bonded joint performance. The selected adhesive must be evaluated with the actual core, skins, surface preparation, cure cycle, and pressure conditions. Bond line control, machining effects, resin penetration, and post-cure behavior can influence both structural integrity and construction consistency. The fourth gate addresses structural response. Finished panel testing should assess stiffness, deflection, local loading, and fatigue where required by the design. Coupon properties alone cannot predict how a long panel will behave across its real span and support points. Patient support areas, transition regions, and sections near mechanisms may govern performance. The fifth gate focuses on inserts and other concentrated load paths. Rails, clamps, edges, mounting features, and attachment zones can create demands that broad panel tests do not reveal. Representative hardware and installation geometry should be used to evaluate compression, pull-through, and service loads. Local reinforcement, potted regions, additional skins, or higher density core may be necessary. Environmental durability forms the sixth gate. Repeated cleaning, humidity, storage, transport, temperature changes, and equipment operation can affect dimensions, surfaces, bonds, and imaging behavior. Conditioning must reflect the device's actual exposure profile, followed by inspection, dimensional checks, and appropriate retesting. The seventh gate is manufacturing control. A successful prototype does not prove repeatable production. Core placement, adhesive handling, resin charge, vacuum practice, cure measurement, machining, finishing, and dimensional tolerances all require controlled instructions and records. First article inspection should confirm that the production process reproduces the qualified construction. The eighth gate is traceability and change control. Changes in foam grade, density range, supplier, manufacturing location, adhesive, skin, cure profile, conversion route, or geometry can affect previously accepted evidence. Lot records must connect each assembly to its material and process history, while defined rules determine whether a change requires review, limited retesting, or full requalification. Supplier decisions can then be organized around 6 weighted areas: imaging compatibility, finished panel structural performance, bonded joint performance, durability and cleaning resistance, process consistency, and traceability. Imaging and structural performance carry the greatest emphasis, but qualification is not merely a numerical score. Missing critical evidence cannot be offset by an attractive density figure or a strong result elsewhere. A pass means the evidence applies to the exact design and meets its acceptance range. A conditional result identifies an unresolved assumption. Insufficient evidence means that information exists but does not answer the required question. Production release is complete only when the approved material description, representative test results, purchasing documents, incoming controls, work instructions, inspection plans, record ownership, and change notification requirements all refer to the same control design. That is what turns a promising foam core into a defensible, repeatable imaging table structure.